In this video, we're going to be tackling the LeetCode question, spiral matrix. So in order to understand this question, we must first understand something very important about matrices, and that is, why exactly do we have two brackets at the end of a matrix? It seems kind of unsightly, to say the least. Just two brackets at the end of a data structure like that is kind of strange looking, and it seems rather unintuitive. But in fact, it is very intuitive because we have those two brackets to access things in a row and column basis. Very similar to how we would access an Excel spreadsheet. Let's just have a very simple example. Let's say we want to access the 0 row and the 0 column in our matrix. And we've been given an example by LeetCode to spiral throughout. And the 0 row and the 0 column would be the 1 in this example. I've went ahead and did you a solid and turned the matrix that we are going to spiral throughout into a nice little graphical cube right here, but it pretty much represents this in the matrix form. So if we're going to spiral throughout, here's how it's going to work. We're going to go from top left to top right, from the top right to the bottom right, from the bottom right to the bottom left, then we're going to go to the middle, then we're going to spiral into the 5. How exactly are we going to represent this in an algorithm though? Just like any algorithm, we're first going to have to initialize state. And the state that we're going to create is going to represent, just like we talked about before, rows and columns. Pretty much the X and the Y coordinates for the matrix. How is that going to work though? It's actually going to be pretty simple. We're going to initialize 4 variables, up, down, left, and right. Up and down are going to represent our rows. Left and right are going to represent our columns. And you can see the correlation here. The up is going to start at 0, which is going to be, you guessed it, our top row. And the down is going to be initialized as length -1, pretty much our bottom row. With the state that we just created, we're going to form 4 for loops. As we iterate, we're also going to keep track of our data in an array. So the very first iteration is going to be very simple. We're going to take our first for loop and we're going to iterate from the left to the right, and we are going to add them to our array. So I'll just go ahead and add 1, 2, 3. Then what we're going to do is we're going to form our second for loop, and we are going to iterate from the row right underneath the one that we just iterated to the bottom right. And we will add our 6 and 9 to the array. Then we will form our third for loop, and we will iterate 1 column to the left to the bottom left element. And we will add those 2 elements to our array. So it'd be 8 and 7. And for our last and final for loop, what we're going to do is we're going to iterate 1 row above the bottom element and 1 row above the top element. And in this case, we're just going to iterate through 4. So we will add 4 as our element to our array. The thing is though, is that we still have the 5 to worry about. Not only that, but let's say we had a bigger example. What if we had a bigger matrix with, say, 4 or 5 columns? We would also have to spiral within our spiral, so to speak. What we're going to do is, for our global state that we created, we're going to increment the up, we're going to decrement the down, we're going to increment the left, and we're going to decrement the right. What this is going to do is this is going to prevent us from visiting rows and columns that we have already visited. And after we get done incrementing and decrementing like we have just done, the second time that we run through all of those 4 for loops, only the 5 is going to be left, and we can go ahead and add that to our array. Not only that, but this will also handle cases like in the case where I had, let's say, 6 or 7 columns. This will also spiral within the spiral, so to speak. So let's go ahead, let's hop over into IntelliJ and let's code it. So we are inside of IntelliJ, and the first thing that I'm going to do is create a brand new Java class, and I'm going to call this solution. Within the solution class, we will house our method, and this method is going to return a list of integers, and I am going to name it spiral order. Also, it will take in a parameter called matrix. So now that we've got the method built, let's go ahead and import our list. And let's go ahead and create the data structure that we're going to use to return our data. We can call it anything we want to, but I'm going to call it result. And also, the AI is popping up with null checks and edge cases. So let's go ahead and return the result if we trigger any of those edge cases. And by that time, it will just be an empty list, which is what we want. So we're going to do a bit of destructuring. Technically, we don't have to do this, but it gets very cumbersome to write matrix.length over and over again, and we'll also do this for the columns. It also adds a nice touch. So here's where we're going to declare our X and Y axis. This is where we're going to declare the up, down, left, and right. So AI is going to do most of that for us, but let's just go ahead and walk through everything step by step. So these are all going to be ints. Notice that the down is going to be the rows -1, and that's because we want the bottom row. Also, left and right. Left is going to be 0, and right is going to be cols -1 because we want the length. We want the value across. So we've got our state figured out. Now what we're going to do is we're going to begin our iteration. So AI, once again, AI is on a roll today. It's taking care of a lot of things for us, but let's go ahead. We're actually going to change this out a little bit. Let's go ahead and swap this out. We want to be if up is less than or equal to down, and we also want to check if left is less than or equal to right. And basically, that's going to make sure that our values don't cross over each other. And if our values ever cross over each other, we want to exit the while loop. So here's where we finally get to the fun part. What I'm going to do is I'm first going to initialize a column variable, and I'm going to set it to the left. We don't have to do this, but it makes it way easier to reason about when we have to look at it later. And we're going to iterate from the column, which is the left, to the right. And as we iterate from the left to the right, we're going to go ahead and we're going to add all of these individual elements to our result list. And I'm going to reach into the matrix, going to access it with the double brackets, and we're going to go ahead and declare the row as up and the column as col. And that's going to add all of those variables along the top. In our previous for loop, we iterated from the top left to the top right. Now what we're going to do is we're going to build a for loop that's going to iterate from one row beneath where we just ended to the bottom right. How exactly are we going to do that? Well, we're going to design another for loop. And instead of initializing a variable at the column, we're going to initialize a variable at the row. And we're going to say up +1. Because when we add 1, we're going to start one row below where we just stopped. Then what we're going to do is we're going to iterate from the row down. We're going to increment along the way to the row. And just like we did before, we're going to add these results to our matrix. And we're going to say row in the first bracket and right in the second bracket. Then what we're going to do is we're going to iterate one column to the left of our last column to the bottom left column. Then we're going to form another for loop one row above and iterate till we reach one row below the top column. How exactly are we going to do this? Well, we're going to be using for loops. But before we actually loop through anything, what we need to do is we need to make sure that we're not iterating over anything we iterated over previously. And the way that we do this is we check if up and down are not equal, if we're not on the same row, if we have not been to this row before. And just like our previous for loops, what we're going to do is we're going to initialize a column. But this column is going to be a little bit different because we need to minus by 1, because we need to go over one element to the left. And also we need to iterate backwards. So we're going to say if call is greater than or equal to left, and we're going to decrement the call. Just like before, we're going to add each element that we iterate over to our result list. Now what we're going to do is we're going to do the same exact thing, but we're going up this time. Just like before, we need to make sure that we're not iterating over the same stuff. But before we were checking if we weren't iterating over the same row. Now we need to make sure we're not iterating over the same column because we're going up. Once we've made sure that we're not iterating through the same column, we can begin moving up row by row. So we'll go ahead, we'll initialize a variable, we'll call it row. We also don't want to start at the same row that we ended on. So we're going to go ahead, we're going to -1, so we go up 1. Another thing is we don't want to end on the top row. So what we're going to do, instead of saying greater than or equal to, we're just going to say greater than. And also we're moving backwards, so we're going to go ahead and we're going to decrement it. And along the way, as we increment, we need to make sure that we're adding all of these values to our result. And we're going to add the matrix with the first bracket row and the second bracket left. Last piece of the puzzle, we're going to go ahead, we're going to do all of our incrementing and decrementing. So we're going to increment up, we're going to decrement down, we're going to increment left, and we're going to decrement right. And finally, last but not least, the final linchpin of the puzzle, we return our result array, all of the elements that we put into it. So let's go ahead, let's copy all this, and let's see what we get in LeetCode. So I'm going to go ahead, get out of full screen here. I'm going to drag this over, paste the code into the editor, and bring this over. Let's go ahead, run our test. Please, thank you God, they are accepted. Let's go ahead and hit the submit button. We are at MN for the time complexity, which is great for this particular LeetCode question, and our memory is MN as well too. Anyways, hope that you guys enjoyed this. If you did, make sure to smash that like button, smash that subscribe button, and as always, thank you for watching.